Right. Today we want to talk about APIs. Let's do this. So at this point, actually let me open up the homework doc. Oh my goodness. So at this point in your homework, you have everything you need to do both learning objectives and the first application objective, which you've had for a bit. Monday was just examples to help you out, help you get started. But you're able to do all the Docker setup now. That's what we've been talking about the last 3 lectures. You've been able to do the learning objectives for quite a while, hosting your site, hosting your images. We've been able to do this stuff. Now that we have all the Docker Compose up there, you're able to get through application objective 1. And today we're going to do application objectives 2 and 3. This is kind of one thing. It's just the API, but it's broken into 2 application objectives because it's quite a bit of work. You deserve 2 objectives for it, so it is split into 2. So let's talk about how to do the API. Application objectives 2 and 3. That's today's content. And then Friday is going to be another examples lecture. It's going to be demos and just showing you more stuff to help you get started. Hopefully not get started, but finish up your project. So let's get into it. API, Application Programming Interface. I assume you all know the acronym by now. API is effectively how 2 pieces of software communicate with each other. So we're going to create a web API, and that's going to define how other software out there is going to consume our software. We're going to expose a public API. They're going to hit those API, what we call endpoints, which are going to end up being HTTP requests for our purposes because it's a web app. And that's how other code is going to interact with our code through an API, for our purposes, a web API, or as we'll see, a RESTful API, which is a RESTful web API. So what's the problem we're trying to solve is how do we do data? How do we even do that? We have data. Most apps, any app with any sort of interest to it is going to have some data that it's going to store. It's going to store usually data pertaining to the users. We need to be able to control that data in some way, allowing people to access, update, delete, etc. that data. I'll let you read the examples. But the question that I have for you, that I'll answer also, is how do we let our users interact with that data? We want our users to be able to access that data and interact with it in some way. If they're adding items to their shopping cart, they need a way to be able to do that. We need to build the code that enables that. How do we do it? That's all about today's lecture. And this is the answer. Yay. We learned it. So the user is always going to be working in a web browser. I shouldn't say always, but the user is going to be working on their machine, which is going to talk to our web server, our HTTP server, which is your code that you're writing for your homework. And your server is going to communicate with a database. For our purposes in Docker Compose, your app is going to talk to an external database that the end user, isn't going to talk to directly. The user has to talk to your server talks to the database. So let's break this into each piece of communication at a time. And we're going to start with how your server talks to the database. And then after that, we'll worry about how the user is going to communicate with your server. So how does our server interact with stored data? CRUD is the answer. So CRUD operations, these are standard database operations that are the 4, and as we'll see in a second, 5 common operations that we'll use to work with a database. CRUD, the acronym standing for create, retrieve, update, not destroy, delete, but I'll think of it as destroy. These are the 4 basic operations we can do to data. We want to store data, update the data that we stored, retrieve the data that we stored, and delete the data that we stored. So 4 things that you're going to want to do with your data, right? So we break that into the 4 basic operations, the keyword being basic here. You might be tempted to add some more complex functionality to your data. But it's typically better practice, stuff that it doesn't catch up to you later as much if you just stick to the 4 basic operations and work with those 4 operations instead of adding more complex endpoints. You stick with the basic ones and let people access your data through CRUD operations. So let's go through these one at a time. Creating a new record. In SQL, this is our insert into a specific table. In MongoDB, it's inserting into a document into a collection. This is going to create a record, and it's usually good practice and required for your homework to assign a unique integer ID to your values. If you're using SQL, there's an auto-increment feature in SQL that'll just assign your IDs for you. The first record is going to have ID 1, second one ID 2, et cetera, et cetera. And that will store this auto-incrementing ID. And it's pretty common to just have either an auto-increment like this that starts at 1, or to have some randomly generated unique ID and use that for your IDs for your values. But some unique ID for the homework, you'll have to have integer IDs like this. So if you're using MySQL for the homework, just slap an auto-increment on your table, and you'll get you'll get these generated IDs for you. If you are using MongoDB, there is no auto-increment functionality. MongoDB will create an _ID variable for you for every single record, which uniquely identifies that record. You can't use that on your homework. It's not an integer, and we require integer IDs for your assignment. So you can't use that _ID when we're testing your code. We should never see those _IDs when we're hitting your endpoints from Postman, but we haven't talked about that yet. But we shouldn't see those _IDs. Unfortunately, you will have to come up with a way to manage and store those IDs as integers in your Mongo database. My recommendation for that is to create a separate collection that just stores the latest ID, and then whenever you have a new record being created, hit that collection, say, hey, what's the latest ID? Bump it up by 1, update that record in that collection, and then use that ID in for your new record that was added. So there is a little bit more work if you're using MongoDB. MongoDB cuts out a lot of work, but this is one case where it's going to add a little bit of work to you that MySQL does handle. Retrieve. In retrieve, when I said we'll see 5 things instead of the 4, this one is kind of hiding an extra one. Retrieve has 2 separate ways to retrieve. Either retrieve a single record or retrieve all of them. So retrieving all records of a specific type, our select star or our find empty query is going to give us all the records. And this is usually called list. So the acronym is actually CRUDL, but I think that sounds dumb. So I just call it CRUD, even if I have a list operation as well. If you like CRUDL, that's whatever, that's fine. Use it. But if you do hear CRUDL, because I'll usually say CRUD, if you hear CRUDL out there in industry, somebody saying that, just know that that is the same thing that we're talking about here. It's nothing new and fancy or anything. It's just a worse sounding acronym. Retrieve, if we want to retrieve a single record, we're going to retrieve it by ID. So those integer IDs that we assign our records, we're going to say either give me select star where or find with an actual query, and find just the record with the ID that's being requested. So give me just that one record with that ID is our actual retrieve, not the list. Update an existing record. In SQL, it's update where. In MongoDB, this is the first time we're seeing a little extra syntax in MongoDB. We call update. The first filter is the filter. I spoiled it, I guess. But the first key value pair, key value store is going to be the filter. It's going to say, this is like filter. I could do this. The update where ID equals 5, and this is what should be updated. So we're going to see this first kind of MySQL command we're going to give it this set command, which says set any of these values. So in your homework, you're updating the email and username. So you'll say update where ID equals whatever record you're updating, and then set the email to whatever the new email is, and the username to whatever the new username is. So we're going to filter and then update just the records that were filtered, which is the same thing for MySQL. We're going to filter where ID equals 5 and set email and username using our prepared statements, of course, always using prepared statements for SQL. So we don't have SQL injection attacks. Yeah, CRUD. I'm trying to think if there's a better acronym. If we throw an L in there, curdle? Curdle don't sound terrible. Like, it does, but it doesn't. At least it kind of resembles a word. Maybe not the word we want to associate with our database, though. So when we update, we can update all fields in our records except the ID. Like, technically you can. Like, physically you have the power to write the code to change an ID, but you never ever should. Don't change an ID in your records. So the idea here is that somebody's storing a record in your database, and then you give them the ID and say, here's the ID of the record that you just stored, and that's how they're going to update and access that record, or delete if they want to delete it, is by ID. If the ID changes from underneath them, they don't know how to access their data anymore. So we don't change the IDs. That's a unique identifier, and it should stay constant. That should always be the same for the lifetime of that record. And finally, delete. When we delete a record, delete where ID equals 2, delete where ID equals 2. The syntax is pretty clear there. It's just the same as a retrieve. We just use delete instead of find. When you delete a record, it's very common in practice. By the way, you can do whatever you want for the homework as long as you satisfy the homework description. In practice, it's very common to just soft delete things. We very rarely, as software engineers, actually delete things. It's a rare thing to just delete things. We like data. We want to store that data. We want to have that data. So instead of deleting it, we just mark it as deleted. And then once something's marked as deleted, we never send it to users or anything. We just treat it as though it were deleted, as though it were gone. But in the database, sitting in the database, it just has a flag that says deleted, or a timestamp usually of when it was deleted. So we don't actually delete things in most cases. This allows some extra functionality. What if the user accidentally deletes something and says, oh crap, I deleted that in accident, and wants to retrieve that deleted data? Well, if we actually deleted it, we have to say, hey, sorry, sucks to be you. But if we soft delete it, we just say, oh yeah, no problem. And we remove the flag that says it was deleted. All of a sudden, our software picks up on that data again, and they have access to their data again. Another reason to soft delete is that it preserves history, especially if you have a bug that you're debugging. You're in production, a user has an issue in production, and you're trying to debug, you're looking through logs, you're looking through the database and trying to figure out what happened here. And if it was a bug that was exposed by something a user did, like some data a user uploaded, but then that user deleted the data afterwards and you actually deleted it from the database, you don't have your test case there. You don't have your ability to reproduce that bug easily because you don't have the information of what caused that bug. You actually lose history, you lose information. We don't like that in software engineering. We want to know everything that happened with our app. And if we lose part of the history of what our app did, it makes it harder to debug things when issues do arise. So if we have that soft delete, we just see that something was soft deleted. We look at that data, put it in our dev environment, see if we can reproduce the bug, and then fix it that way. A hard delete, can't do that. Can't do it. Clutter, I like that. Clutter's a good one. It's all our database is a bunch of clutter. And we don't even clean up our clutter. Is soft delete the idea behind recycling bin? Yeah, that would be the same thing. Like our soft delete is when something goes into your recycling bin. Even when you delete out of your recycling bin, your OS on your file system just marks those files as deleted. It doesn't. Your operating system actually doesn't delete files either. It does soft delete. But it does, when something's soft-deleted on your operating system, it does allow new files that are written to overwrite that space. So eventually you'll lose that information, or else you'll just fill up your hard drive with soft-deleted stuff. So if you delete something, let me frame it in this context. If you're trying to hide things, you have a bunch of illegal activity and you just delete all the files, and the FBI, whoever investigator recovers that hard drive, they can still access all that stuff you deleted. There's actually a course in the business school, computer forensics, that talks all about that. It's super interesting. But they can recover all the information off your hard drive unless you do a bit washing, where you literally run software that goes through your whole hard drive and just writes straight zeros over everything and erases it. Sometimes they'll run that program. If you really want to hide stuff, you run that program 7 or 8 times, make sure all of that information is actually destroyed and there's no way to recover it. And if you don't want to do all that, but you want to make sure nobody recovers your information, good old-fashioned hammer usually works. Just take your hard drive and smash the shit out of it. That usually works pretty good. Something to be careful about, but more realistically, hopefully you're not deleting illegal activity and stuff like that. But if you're selling a used computer to someone, make sure you're wiping that hard drive in a secure way. Don't just reinstall the OS and call it a day. You want to actually wipe that information. If you got some sensitive information that was ever stored on that hard drive and you're not wiping it clean, somebody can recover that. And they might, there are people who just buy used computers for that purpose, trying to just recover data and find some personal information. If they find the password to your online banking, they can just clean you out. Make sure you're not doing that. And if you have your browser, for example, if you have your browser store your passwords for you, somebody can get that if you sell a used computer. So even if you're just throwing out an old computer, take the hammer to the hard drive. It's good practice. And if you do actually want to sell it and get some value out of that hard drive, make sure you're doing something very secure. Securely wipe that thing. But anyway, so operating systems do this too. Just in general, software engineers, we do that. We soft delete things. So how do users interact with our server? Delete the system32 folder. I don't recommend that, but that still wouldn't delete your data. Again, it'd be soft delete. You just break your stuff. Yeah, even a hammer might not work. But with a hammer, somebody really has to want that data. Hopefully nobody wants your data that bad that they're going to recover that. But if you are running a crime ring and you have really bad stuff on your hard drive, yeah, the FBI is going to invest, or whatever group is investigating you. They can still get past the hammer strat. So maybe hammer plus fire would probably do it. Even then, there could potentially be ways. It just depends how bad somebody wants your data. So any questions on the database stuff? I went through that pretty quick, but I think that's pretty palatable content. I'm just showing some queries and stuff. By the way, when I'm showing the MongoDB queries, this isn't technically any code. This is MongoDB statements. When you run pymongo in Python, there's no update, there's no find. You have to do find one, find many, update one. You have to use those methods. So this is just generic MongoDB code, just for when that does inevitably trip up a lot of you. You are expected to still read the documentation for your specific client libraries that you're using and find out what the exact syntax is there. There's going to be different capitalization on the method names depending on what languages you're using. There's going to be a lot of slight differences. That's on you to find the documentation for. But any questions on this so far? Yeah, burn your hard drive. Burning it would be good. Well, one, just don't do anything so bad that somebody's trying to find your data, going through that much effort to find your data. But if you are, yeah, burn that stuff. Burn that hard drive. Okay, so how do users communicate with our server? They're going to use HTTP. And this is where we're going to see more than just get and post. We're going to see a couple of other HTTP request types, put and delete specifically. and they're going to make an HTTP request corresponding to one of our CRUD operations. They're going to get to retrieve, post to create, put to update, and delete to delete. Let's go through these one at a time, see what's going on here. So post, and put are two different things. So what all these, so far, the way I've said these HTTP methods was get if you're getting things, post if you're sending things. And I just left the conversation at that. I'm going to introduce put today, and put is also to send things to the database, to the server. So what's the difference between post and put? Why do we need two things that do the same thing, that are both meant to send data to the server? So the difference, which is kind of subtle, post is if the server should be processing that data. If the server has to do something to process the data, use a post request. And by the way, these methods, like you're parsing your HTTP requests at this point in your homework. Hopefully you're all at least at that point. When you read the method type, bless you, when you read the method type, it's just a string in the request line. There is zero magic to these words. They're just strings that are on your request line. And it's all just convention, how we all communicate with each other as developers. We're going to use post if this is what we mean. If I say I have an endpoint, make post request to this endpoint, I mean my server is going to do some processing. So be aware of that. If I say put, if I say this endpoint accepts put requests, it's just a 3-character string at the beginning of the request line. But what I'm communicating to anybody using my API is that my server isn't going to process anything. If it's a put request, the server doesn't process anything. So with a post request, we're going to use post to create our records. And when we create a record, the user's going to send, for the homework at least, the user's going to send username and email, and our server is going to generate an ID. So that's some processing that our server is doing. Our server is going to generate that ID for that user, and then return the ID and the username and email. So processing that was done by our server. We generated data. That was an important thing that a server did. So make it a post request to communicate to people, hey, I'm going to do some processing on your data. Put request means the user is just directly throwing things in the database, and our server isn't processing it at all. Our server isn't doing anything to it. A put request must be idempotent. I have a whole slide on that, so I'll save that conversation for a little bit. But a put request, your server doesn't do any processing. It's just going to straight up throw it in the database in our case. Oh, slide's right here. So idempotent, I guess I'm talking about it right now. So idempotent means if you send multiple identical requests, it's going to be the same thing as sending one single request. So I probably should, let me go over the homework a little bit, because if you haven't read the last two objectives, a lot of this might not make sense yet. So for the homework, you're going to create a post request where users can create a record. They're going to add a record to the API. They're going to give you a username and an email address. You're going to assign it an ID and then return them that new record that was added to the database. And of course, you're going to store it to the database. Put request is going to be our update, where they're going to update a record. They're going to say, I need to update the record with ID 5, and this is the new email address and username for that record. And then we update the database and respond to them and say, you're all good. And then when they retrieve that record, they should see the updated values. So if somebody sends two post requests, say we just spun up the server, there's no information in the database, and they say, I want to store a record with this username and this email. And we say, okay, here you go, you got ID 1. Say we're using auto increment in MySQL where indexes start at 1. It's going to say, okay, here's record number 1, it has ID 1, it has the email and the username that you specified, and then the user says, cool, and sends the identical request one more time. What our server is going to do is create a new record with ID 2 and say, here you go, I created a new record, it's ID 2, does some processing, it's ID 2, it's with this username and this email address. That is not idempotent. Sending two post requests, was not the same as sending just one request. But when they send a put request to update a record, They say, I want to update record 5. Here's the email address and username. We update that record 5 and say you're good. They send another put request and they say, I want to update record 5, identical request. I want to update record 5. Here's the new username and email address. And it's the same username and email address. We update the record, which actually doesn't change because it already had those values, and we respond with, you're good. That was the same exact as just sending it once. We're updating the record twice. The second one didn't have any effect on the state of the database or the state of the API. That's idempotent. If multiple requests have the same effect as sending a single request,